equals y is x plus 3 times x minus 3, x minus 1. You can see that factored form means it is already factorized, so it is in the factored form. So when the question is in the factored form, please don't go and expand out and go and get into the general form. Actually, from the factored form, you can see more things. Okay, what can the things that you see? Okay, for example, if you put this to be equals to 0, okay, if you put it equals to 0, you can see that x plus 3 is 0 or x minus 1 is 0. So your x is actually a negative 3 or your x is equals to 1, which means if you were to draw, okay, if you were to like simple sketch and not draw, okay, you have a simple sketch, the point at y equals to 0, which is the x-axis, okay, this point x is at negative 3, and then this one is at 1. Okay, so you have these 2 points of the graph already. Then next is, if you see that this is 1, this is negative 3, the beauty of quadratic equation is that when they are symmetrical. So they are symmetrical. So for example, you want to find where's the maximum point or where's the minimum point. So you want to find the turning point. You are going to look for the center of this line. Okay, the center of this line, this full length is 4 units. If you divide into 2, that is 2 units. And when you have 2 units, that means this is where the center is. Okay, so that means a line of symmetry is going to pass through the center here. The center here. Okay, so that's where the line of symmetry is. So if you want, you can even do some calculation when x is equal to negative 1. So negative 1 plus 3 and then negative 1 minus 1. So this will be negative 2 and 2, so it's negative 4. So you have the minimum point at negative 4. So you see, you can have one more point which is negative 4. And another point that you can use is when x is 0, so you have 3 times negative 1, so which is negative 3. So just now this was negative 4, so negative 3 is going to be here. So can you see? We have 1, 2, 3, 4 points already. So you see, you know that this is the turning point. So you join this part to here and then extend it. And then this part is supposed to be symmetrical to the other side. So this is how you sketch the graph. Understand? Okay, so this is when it is in the factored form. Okay, next one, it is in the vertex form. What do we mean by vertex form? Vertex form, from the word vertex, you can understand that it means you want the turning point, the tip, either the bottom, right at the bottom or right at the top. Or maybe guys, okay, for example, y is x plus 5 squared minus 3. This kind of equation is a quadratic equation and it is the vertex form. Okay, so the vertex form. So here, how do you make use of this vertex form? So you can see, how do you tell that it's vertex form? See, vertex form, because it's a quadratic equation, you can always see a perfect square and then plus some numbers here. So this is a constant here, okay? And then this part is always a perfect square. Okay, you will always see a perfect square plus some constant. So this kind is a vertex form. Okay, so vertex form, very obvious. You know that you can find vertex. That's why it's a vertex form, right? So where exactly is a vertex? The vertex will be when you put x to be equals to negative 5, your y is negative 3. Why I say that? Remember the perfect square here? The perfect square here, something square. When we say something square, the something inside can be positive, can be negative, right? And if we want to make this the bigger the better, then our value of x, we can keep on changing into something absolute value very big. Then we can get very big number. But what is the smallest number that we can get? So the smallest would be when x is equals to negative 5. Because why? When inside the bracket is a 0, when you square it, it's going to be 0. Okay, so 0 squared, so it's going to be 0. So it's going to get us the minimum point in this case. Okay, why you know it's minimum? Because you can see that this is x squared. In front there's no negative sign. So which means the a is a positive number. So when A is positive number, the graph concave upward. Okay, so when it concave outward, so you can see, if you were to have a simple sketch of the graph, this is x, this is y. When x is equals to -5, okay, so 3, 4, 5. So when it's -5, you're going to get your lowest point. So that is going to be -3. So you see, this is the crucial point in your graph, okay, because this is a vertex. So this is a vertex. Okay, you see, so this is a lowest point. Oh, how I tell is lowest because this is A is a positive number. So this is going to be negative, positive. The value is negative lah, but it's the lowest point. So this is the minimum point. Yes, it appears. Can I? Okay. Maybe this is the answer for question 1. Okay, maybe I go through briefly. You see that the question give a general form. So you see the general form, we look for the A. Okay, this is A. Okay, this is A. So A is -2. So you know the graph go downwards. Okay, then C is where it cuts the y-axis. Okay, and then B later we determine. Okay, so the graph is given to be, you see, 0, 0, and 3, 0. Okay, so when it's 0, 0 means it cut the y-axis at 0. So when it cuts y-axis at 0, so we can see that 2C is 0. You see it go blank again. Oh, now it come back again. Okay, so C equals to 0. Okay, so our C can be determined very easily because it determined by the y-intercept. Got it? Okay, then next, you now simplify the equation into this without the C already because C is 0. So now the equation becomes only with B unknown. Okay, so if you put x to be equals to 3, y equals to 0. Why you put this point? Because this is one of the point on the curve. So that means it must satisfy the equation of the curve. So I put y0, x3 in. I'll be able to find what is b. And the b now is 3. So when the b is 3 now, I know what is the equation of curve already. So this is the equation of curve. Okay. Then the next part, they ask you, what's the coordinates of the turning point? So turning point, because this is quadratic, right? See, quadratic, right? Power 2. So quadratic graph have this very special properties that it is symmetrical. So when it's symmetrical, means that the maximum point or the minimum point should be somewhere in the center of these 2 points on the x-axis. So if I know that this point is 0 and this point is 3, so the midpoint of 0 and 3 will be 1.5. So that means when x is equal to 1.5, that's where the turning point is. Okay, so in this case, it's a maximum point. So you see that the turning point is maximum. Okay, maximum point in this question. And how do we get the x value? We take 0 plus 3 divide by 2. So that's 1.5. Okay, and then we put 1.5 into our equation. We look for the y. So we are able to find the coordinates of turning point. Clear? Diagram shown is the diagram at the right bottom there. Okay, the right bottom, given point A, given point B. Point A unknown, point B unknown, but the equation given. So whenever the equation given, we can determine A, we can determine B. Okay, so we can determine A and B. So here, we will be able to get A and B. How do you know A and B? When you put this to be equals to 0, your x will be -3, your x equals to 1. So this point is at -3, 0, and then this point is at 1 and 0. Okay, so if you want to find coordinates of A, it will be just -3 and 0. Okay, then the next part they ask you, say that if there's a point P on the graph which is having coordinates 2 and P, how do I find the value of P? So I just need to know what is the equation, and if I know what is the x value, what I do, I will just substitute x as 2 into the equation. I can calculate the value for y. And the value of y is just the value of p. So therefore, p is equals to 5. Clear? Okay, then next is, they ask you, okay, if now I have one point here, and then I have another point here. If I want to join them by a straight line, so you see the red color line, so that is a line that they want to form, and then form this line, and then after that, find equation of this line. So if you want to find equation of line, we know that equation is of the form y equals to mx plus c, straight line equation, y equals to mx plus c, right? How do we find the m? So the m will be the gradient, right? So we have 2 points. So with the 2 points, we substitute y2 minus y1 equals to x2 minus x1. So we calculate the gradient as 1. So now we know the equation is y equals to x plus c, because y, the m is 1. Okay, then if I want to find the equation, because I still have the c unknown. So if I still have the c unknown, so I want to find the c, I just substitute any point on the straight line to get my c. So I choose the point 2, 5. You can also choose the point negative 3, 0 to find. It's the same. You're going to get your c value to be 3. So when c value is 3 already, then you can determine what's the equation of the straight line. Is that clear? Got it?